Good afternoon, everyone, and welcome to this BGS webinar to introduce GeoCoast, a new package of data sets designed to inform and support coastal management and coastal adaptation planning, particularly within the context of coastal erosion, subsidence, and inundation. Thank you for showing interest in attending. My name is Patrick Gray. I'm from the digital products team here at BGS, and it's my pleasure to host this webinar. Over the next 30 minutes, you will hear from research, from product, and from commercial colleagues, whom together will provide an overview of the data, the science that underpins it, and the practical uses from the insight. In terms of running order, Katie, whom heads up our geohazards product team, will introduce a proposition. Chris and Rob, who are both geospatial environmental modelling experts, will then talk us through the data, the methodology, and the output. And then Henry will present a case study to help bring the data sets and their applicability to life. Finally, before opening up to Q&A, Katie will explain how you can access and license the different data sets. But before we start, just a wee bit of housekeeping. Firstly, we are recording this session and we will make it available afterwards. Secondly, please use chat for general comments and the Q&A function to submit your questions. We will try and answer as many questions as possible during the Q&A at the end, but we will also arrange conversations following if necessary. And thirdly, we will wrap up in about half an hour's time. I hope you enjoyed the webinar, and I will now hand over to Katie. Thank you.
Thanks, Patrick. Hi, everybody. Great Britain is an island nation. It's surrounded by over 30,000 miles of coastline. And this coastline is incredibly diverse, both in terms of its geology and its geomorphology, ranging from the high chalk cliffs, say, of Sussex, to the flat expanses of the Wash and Morecambe Bay. So coastal resilience is a key issue, and especially for those who work and live around our coastline. In recent years, we've witnessed numerous examples of coastal flooding, cliff falls, and damage to infrastructure, businesses and homes during storm events. These current annual damages from coastal flooding alone are estimated at over £500 million a year. And that will only look to increase under projections of future sea level rise. As well as homes and infrastructure, we also have historic value that's under threat. Things like buried archaeology and historic structures such as the Godwin Battery and Spurn Point, they've already been lost to coastal erosion. And the National Trust, for example, often carry a huge repair bill for costs on the more regular winter storms. So if we look at the scientific literature briefly, there's a wide variety of methods that are used in the assessment of coastal vulnerability to climate change. In choosing the most appropriate assessment, we need to consider key factors. So firstly, having a clear definition of the objectives. Secondly, identifying what the problem is or the policy question that needs to be evaluated. So far, for Scotland, Wales and England, they've developed their own assessments of coastal vulnerability or coastal change. And GeoCoast is designed to complement these. So it considers all three nations together as a whole, and it identifies the geological factors contributing to coastal change. And this component is key to informing that broader, more extensive assessments for the whole environmental setting. So what is GeoCoast? It's an integrated suite of GIS data sets, and it's designed to inform and support coastal management and adaptation. It contains data for the whole coastline of Great Britain, including most of the islands, and also including those key geoproperties that can affect that coastal zone and its resilience. So it includes both open and premium versions, which we will talk about during the webinar. And the icons you can see along the bottom indicate the multiple components of the data product. We've developed GeoCoast, as I say, from the geo perspective to help understand and inform. And as shown on this slide, that we can highlight the problem, such as erosion or sea level rise, and then identify the associated data that GeoCoast provides to help tackle that issue. It's also important to note that the development of GeoCoast has been underpinned by stakeholder input, and I'd like to thank the focus group who trialled a beta version for us, and they provided some really useful feedback that's helped shape what we're launching today. So I'll now hand over to Chris, who will provide an overview of the data sets that create GeoCoast.
Great, thank you, Katie. Yeah, so as Katie just said, I'm now going to give an overview of the different versions of GeoCoast that will be available and the various components that are contained within. So this is very much going to be a high-level overview, and as with all BGS products, a detailed user guide has also been compiled, and we encourage all users to review this prior to working with the dataset so that they get a proper handle on what's contained. So the GeoCoast product has been developed for Great Britain, therefore covering the coastlines of England, Wales and Scotland and the islands. The product does not extend to Northern Ireland. And 2 data packages have been made available. We've got GeoCoast Open and GeoCoast Premium. So firstly, we'll look at the GeoCoast Open dataset. So these data will all be openly available to all users under an open government license. As part of GeoCoast Open, we've compiled and are providing all of our existing openly available data records that are relevant within the coastal environment. So this includes historic records, coastal photographs, diagrams, and logs from the BGS archives. Also provided are geological memoirs, sheet explanations, regional guides, and maps. Geological lines of cross-section are also being made accessible where they are available. And also, as part of the GeoCoast Open dataset, we're providing a range of regional statistics for local authority areas and shoreline management plan regions. So these statistics summarize many of the contents of the premium baseline GeoCoast datasets, which we'll cover in a moment, including, for example, the percentage length of coastline within a region of high susceptibility to erosion. And we're providing this information to users in various geospatial data formats from which it's then possible for those users to extract that data and interpret it as required. And the plots we've just presented on this slide here just give some examples of how these data might be used or could be visualized. So a new and significant development that we're also making available as part of the GeoCoast Open dataset are a set of geocoastal domains. So 2 sets of domains are going to be made available. We've got geometry-based domains and domains defined by erosion susceptibility. So what these domains do is they break stretches of the Great British coastline down into a number of more common groups, providing a benchmark for describing the coastline and its potential for coastal change, independent of administrative boundaries. So the erosion domains, as you might expect, are based on erosion scores, whereas the profile domains consider topographic variability based on transects and elevation change. And they're both available as a tool that users can apply to simplify coastal complexity. They can be used directly with the more detailed GeoCoast Premium dataset, which we're going to visit now. So without further ado, this is all about the GeoCoast Premium baseline datasets. So this is the license component of the wider GeoCoast product, and there'll be more details on licensing and access later on. So the GeoCoast Premium baseline datasets are provided on a vectorized 50-meter grid around Great Britain. Each 50-meter cell is attributed where appropriate with information on the following components, for each of which there are multiple attributes. So the first of these is the type, properties, spatial area of the foreshore. We've then got the type, properties, and spatial area of the backshore. Consider inundation potential at a given location under climate change, and this considers future sea level rise forecasts for 2050, 2080, and 2100. And this is in line with the UK CP18 predictions under RCP 4.5. We consider coastal erosion susceptibility based on vertical cliff layers and associated properties, which I'll go into a bit more detail in a moment. We consider cliff profiles, which is based on topographic variability, which covers slope angle, distance to cliff top, and cliff height. Coastal subsidence, which is based on satellite measurements and lithology types. And then finally, the potential of combined groundwater and coastal flooding. So as mentioned earlier, these different attributes are accessible from a 50-meter grid that follows the GB coastline. And this grid consists of cells that cover the foreshore and backshore regions, as opposed to it just being a single string of cells along the coastline. So consequently, in some areas where an attribute may not apply, if you go and click on one of these cells, you might get a no data value. So for example, cliff height is only going to be relevant in certain locations. And what we'll now do is we'll just dig into a little bit further on two of the core GeoCoast components, erosion susceptibility and subsidence, and I'll provide a bit of an overview of how these were constructed. So the GeoCoast Premium Erosion dataset provides the first GB-wide vertical stack analysis of geologies from a coastal erosion perspective. So the image that you can see on the slide here is a cliff section at Black Ven on the South Dorset coast near Charmouth. Now, to assess erosion susceptibility, a team of geologists from the BGS have reviewed sections just like the one you've got on screen now, considering various BGS baseline datasets, which include our 1 to 50,000 scale geology maps, permeability, strength, and discontinuity datasets, together with aerial photography. And attributes per location were relatively scored, then aggregated to provide a normalized erosion susceptibility score. So as part of GeoCoast Premium, users are provided with these erosion classifications, which denote the mean and worst classifications identified within a cliff sequence for the different lithologies present in that sequence. Now, the lithology susceptibility at the base of the sequence is also explicitly described within the dataset, as this is the one that's most likely to be susceptible to coastal erosion when considering processes of wave attack. Subsidence is another important component of the GeoCoast Premium dataset, providing information on coastal subsidence potential based on bedrock geology. So we've considered superficial sediment presence together with this and relate this to subsidence rates from satellite interferometry. So the information we've provided in GeoCoast is a GB adapted version of the Pan-European Subcoast project from 2010. And this tailoring of the European datasets to GB was possible by integrating that information and then calibrating it with various BGS 1 to 50,000 scale products. So that brings us to the end of this brief dataset overview. So I'll now hand over to Rob, who's going to discuss how all this relates to different sectors across Great Britain.
Thanks, Chris. So the GeoCoast data packages are well placed to support a variety of industries, and I'm just going to run through a few examples now to highlight this with you. So starting off with coastal management, planning and development. The GeoCoast data packages have been developed to allow easy access to data pertaining to specific local authority and shoreline management plan regions, making them ideal for utilisation in the coastal management and planning sectors. As already mentioned, regional statistics are available for specific management and administrative regions across Great Britain, and the coastal domains allow for easy comparisons of other stretches of coastline, enabling lessons to be learned and shared between spatially distinct coastal management strategies, and that allows for effective policies to be implemented. Despite recent initiatives such as DEFRA's 25-year plan and the UK Government Environment Act, no specific targets have actually been set in England in relation to reducing the impact of physical modification on the coastal environment, with DEFRA stating that they're interested in exploring this area further with stakeholders to determine whether a target could be developed over the longer term. And this is a good example where GeoCoast can be a key asset, as well as planning and development in relation to other local authority and national government environmental targets across Great Britain. Moving on to infrastructure and asset management. The Climate Change Committee's independent assessment of UK climate risk has highlighted the threat of coastal geohazards to infrastructure networks when it stated that in total, 35 power stations, 22 clean water facilities and 91 sewage treatment works across the UK have been identified as being located in areas at significant risk from coastal flooding. The risk to transport infrastructure located at the coast, such as rail line and roads, are likely to be even more significant as they are not as easy to protect along their entire length. In response to this threat that's been highlighted of ongoing and future climate changes, many industries are carrying out their own risk assessments for their coastal infrastructure networks. GeoCoast provides a comprehensive overview of the susceptibility to coastal geohazards at a nationally consistent and varied temporal scale, making it an excellent resource when determining infrastructure protection and resilience strategies at a regional level, right down to more localised coastal vulnerability assessments. Considering the insurance, property and lender sectors, a recently published UK coastal flood model suggests that financial losses as a result of coastal flooding could be up to 1,300% greater without the protection that's currently provided by coastal flood defences. And as Katie's already mentioned, annual losses due to coastal flooding are estimated to exceed £500 million a year. GeoCoast has identified some 30,000 properties within 25 metres of a highly susceptible to erosion coastline, and some 110,000 buildings potentially threatened by coastal inundation by 2050. And this actually rises to 125,000 by 2080 under the climate change scenarios that Chris discussed. These again highlight the importance of geohazard susceptibility data to sectors involved in planning and developing infrastructure and management schemes in the coastal zone, but it also emphasises the threat coastal geohazards pose to asset portfolios. And GeoCoast data is applicable in this regard to the insurance, reinsurance, property search, and mortgage sectors for assessing the susceptibility to coastal geohazards across those portfolios. And finally, agriculture and water management sectors can also benefit from GeoCoast. So the Climate Change Committee's independent assessment that I've already mentioned flagged the risks to soils and aquifers as key areas in need of further research and greater mitigative action. GeoCoast inundation under climate change scenarios is a useful tool in identifying regions under threat of permanent or periodic coastal flooding and assessing the impacts that this will have on coastal growing regions through changes in soil chemistry, saline contamination of groundwater sources, and farmland inundation. So that was just a brief overview of how GeoCoast can be applied to various business sectors. And I'm now going to hand over to Henry, who's going to run through a use case example of GeoCoast being applied using Esri story maps. Thanks, Henry.
Thanks for that, Rob. So I'm going to give you an overview of the Esri story maps that I've been helping to create for GeoCoast. To access these, you don't need any specific technical skills or software to view and interact with the data. For the purpose of today, I'm going to concentrate on the Haysborough case study story map. This is one of 7 that have been created to depict different coastal environments. And for the purpose of this presentation, I've created some screenshots from the story maps, but in real life, when you get to use them, they're actually far more slicker than this. Okay, with story maps, you basically scroll through it as you would a web page. Here we start with the description of the features in the local area. Any map element, such as this location map, you can actually interact with, and I'm going to show you that a bit further down with some of the GeoCoast data itself. Continuing working our way through, we get to a description of the geology present in the area, describing key characteristics that are in this local environment. And our first map contains GeoCoast data that you can start to interact with, in this case, coast type. And if you click on the double arrows there, that will expand the map itself, and we can start interacting with it by zooming in and out and panning around. So if we zoom in, we can start seeing some of the data present, and any of these data cells we can actually click on, and it will reveal some of the information from the GeoCoast premium dataset. And this example will just show some of those attributes that are present. And if we continue with the story map itself, and we scroll down a bit further, we get to our second map showing cliff height. Again, we can interact with it in the same way as the previous map. So if we expand it, and you can see there's a red boundary around the area, and that is just because we have clipped some of the GeoCoast premium data to these specific case study areas. As we zoom in, again, we can click on any of the data cells, and it reveals different information that has been taken from GeoCoast premium dataset. And if we continue with the story map, continue scrolling down the screen, we get to a series of maps that show cliff erosion. The first one showing worst case classification, the range in which the erosion score lies. And again, same interactions as before. On the left-hand side, you can see we've got a legend which shows what the different colours represent. And again, we can click on any of the data cells. And for this example, the attributes that pop up will show the different lithology types in the cliff itself and the lithology scores that have been associated with them. And because we've got quite a bit of attribute information here, you can actually scroll down the attribute table to show different information. And as well as the worst case classification, we've also got maps that show the mean case classification and the Lith 1 classification. That's the base of the cliff, which is more susceptible to erosion itself. We've also got a map showing inundation rates based upon the UK climate protection data, as well as the subcoast potential subsidence rate data. And again, these can be interacted with on the same way as the other maps. We've also created a range of statistics based upon the GeoCoast open data. This example is showing some of the statistics for Norfolk, which we just visualized for the purpose of the story map. And the next part shows some coastline management information, and any links within the text itself, you can just click on and it will take you to different places to get information. For example, this shoreline management plan of the area. And with the GeoCoast open data, we've also created some statistics and visualized them in this way for the purpose of the story map. So this is the Culling Hard to Lower Stoft shoreline management plan. We've included aerial photographs. This swipe map allows us to see how the coastline for Haysborough has changed over a 20-year period. And you can just swipe between the two maps and it will show how dramatically it has changed within that time. We've got links to other sources of information from BGS, for example, maps and sheet explanations, and you can just click on any of those, as well as links to other sources of information that are external to BGS. Again, they're just a series of links that you can click on that will show appropriate information. And finally, we have a gallery of images which depict the coastline environment, which is shown for this coast study area. You can just scroll through those. But it's worth noting as well, apart from scrolling through the web page, you can click any of the links at the top to quickly navigate through the story map itself. And that's pretty much it. So please take a look at the website, which will have a link to all of the story maps that have been created, and start interacting with the data. At this point, I'm going to pass back to Katie to talk about how else you can access some of the GeoCoast data.
Thanks, Henry. So finally, for further information about the GeoCoast datasets, you can visit the BGS web pages, or you can just search for GeoCoast. And as mentioned previously, we've got both the open and the commercial, the premium versions of the datasets. So the open can be viewed by the BGS GeoIndex, and you can also download a copy from our data web pages as well. The premium datasets, which are the sort of richer, more encompassing suite of outputs, priced based on the shoreline management plan areas. To encourage and enable the use of our data in third-party commercial applications and products as well, we also offer a free data exploration license, and this allows you to evaluate the BGS data and use it in the development stages of any commercial innovation. So to speak to us about accessing the data and the various licensing options, please contact our digital data email, as you can see there on the screen. So I now ask the panel members to switch your cameras back on and invite Patrick to chair a short Q&A session.
Thank you, Katie, and thank you everyone for presenting. So we now have the opportunity to ask some questions, and joining the panel is Andres, who is our lead coastal geomorphologist. So thank you, Andres, for joining us this afternoon. We have quite a few questions that are coming through both on the chat, but also on the Q&A. I'll start with quite an easy one, which is probably just a clarification point. If it's probably for Katie and Chris here, could you please clarify the scale and coverage of the data sets?
The scale is all at 1 to 50,000 scale, so that means that all our spatial searches against the map should be undertaken using that 50-metre buffer. That's similar across all our data products. Chris, do you want to cover the coverage?
Yeah, so I mean, it's a GB coverage, so it covers the coastline of England, Scotland, and Wales. We're not covering Northern Ireland. And as I mentioned earlier on, this kind of 50-metre grid for the premium as well. It's not just a string along the coastline. It very much is kind of the coastal area, so we're capturing the kind of the foreshore and the backshore areas as well. So hopefully that answers that.
Thank you. I'm going to follow on. There's another question just come in, actually, Chris. And it's, when will Orkney and Shetland be added?
I think I'm going to pass that one to Katie.
We don't have any scheduled plans at the moment, but with the next updates, we're always looking to improve. So hopefully we'll add some information in soon.
Okay, that's great. Thank you. So there's a couple of questions here I'm going to try and put into one, and I'm looking at Andres here. So the first part of the question is, are sea defences included in the models? And the second part of the question is, does the erosion susceptibility based on geological layers cover areas where cliffs have been defended against coastal erosion for decades?
Thank you, Patrick. I will start with the second one, because from the question looks like it is implicit that we have been using rate of change to assess the susceptibility to erosion, and that is not the case. We've been looking at the geology and the susceptibility of the geotechnical properties of the lithology to create a database for a number of reasons. One is because the geology is ultimately the last line of defense, if you wish. The other one is because we were looking for a national coverage, so for the 3 nations database, and if we use coastal defenses, not all the coast is defended. There is not a good data set covering the whole 3 nations that provide that data. So that's why we move away from looking at erosion rates and coastal defenses. But having said that, there is an ongoing program to actually use satellite and earth observation to look at the historical rate of change for the whole nation, Great Britain, for the 3 nations, and derive a rate of change from that.
Thank you for that. I'm just scrolling through the Q&As here, so I'm going to ask them as they have popped up. So are any lenders or any lender providers currently using this service? I think I could probably answer that one myself and say the answer is no, as it's only just been released. It's been out there in a beta and been tested for a while, but we're not aware of any organizations actually using it in live services as of yet. Is that correct, Katie, Chris?
Yep.
Yes.
Okay, thank you. Another question here. Are the classifications explained anywhere? What is meant by low, high, etc.?
As mentioned earlier on, yes, a lot of this information, a lot more detail is provided in the user guide. So as and when people access the data, yeah, please go through that user guide, and it does cover a lot of the details as to exactly what is meant where, and how they've been constructed as well.
Yeah, and behind the low, high, medium and things are also values, particularly on the erosion data sets. So the values that are ranked basically from 0 to 100. So each lithology has its own score.
Another question, so can land subsidence rates be traced back? And if so, for how long?
I can take that one, I think. So very much what we're presenting at the moment. So we haven't been considering the rates directly. So as I mentioned earlier on, this is an adaptation of the 2010 PanGeo project. So this has very much been adapting the estimates of rates that were happening within regions and then modifying those to kind of GB geology focused data sets that we can provide. It might be something, if it was something, would we be providing in future? We do have an ongoing remote sensing team within the BGS that are working on these problems. And I suppose that's really a nod to kind of what the future of GeoCoast might be, which might actually segue into something that Andres might want to add to as well.
Chris, I think that you covered everything that I was about to say, so that's fine by me.
Okay, great.
So there's a couple of questions here from the same individual, so I'll ask them both together. First of all is why pin colors to RCP 4.5 when we're on track for 8.5? And then secondly, there's a lot has been said about coastal vulnerability, but little about processes, i.e. a soft rock in a sheltered site is very different for a high energy exposed site. Will you add wave processes and future erosion potential?
Shall I take the first part of that about the climate scenarios? So we selected the 4.5, which is in the 50th percentile, because that aligns to what a lot of the government discussions, so the combined pledges under the Paris Agreement and the similar that was confirmed by the Glasgow COP26 last November. This was the scenario that was closest to that agreement, basically, that the world governments are trying to achieve.
And then in terms of the process side of things, I mean, Andres, I think I've pushed in front of you. I'll let you answer it.
Yeah, no, but I'm happy to if you can follow up, just please follow up. But a couple of comments and also linking this to another question about the coordination between BGS and other monitoring programs like the Welsh Coastal Monitoring Center. So regarding about the future, so what we are trying to provide is historical data, so evidence of change that has actually happened, that this actually inform the models that you might use for the future. That's our approach to that. And as I mentioned, we don't have yet the rate of change, the shoreline change included in GeoCoast, but we are working on that, and then hopefully we'll come soon. And then the other reason is because we are fully aware there is an ongoing DEFRA project on coastal monitoring and historical change, where the Welsh government, the England government are all part of, and actually looking at evidence of change and how can you use those to inform future change is a massive task. So what we are doing is coordinating with all EA, DEFRA, local monitoring programs, trying to make the best use of what we have and don't duplicate effort.
just to, if I can just add a little bit to that as well. So just going back to the second part of that question as well about the processes and how processes were being considered. So the intention of what we're providing is very much trying to provide all those baseline considerations. So those geological components that could be considered. And in terms of going the next step and then integrating all that information into a more complicated, more physically based process model, that's partly where we're providing that data set for the users to work with. And at the same time, if there are more focus regions where there is a demand for that, that is something we can look into. But because we've been trying to get that kind of national coverage and provide that national baseline of coastal focused geological information, we've not gone too far into the full on kind of process level, quite bespoke level of detail. That yeah, is of course important, but it's just not been the focus to date.
Thank you for that, Chris. I'm conscious looking at the time now. We promised to be half an hour and it's been 35 minutes now. And I'm also seeing that the number of attendees is starting to slowly drop, which is a sign I think people are looking towards their lunch now. So I'm just going to pick up a very couple of comments at the end here. Excuse me. Would a GB-wide coastal EO-based land use, land cover mapping help to identify coastal fragility be of use?
I mean, just to kind of give a bit of insight into how we create our products as well. I mean, we're generating products to, provide geological information in the best way possible, and to make it as useful as possible to a range of users. And I think where there are data sets like this that are available, and I see there's, there are lots of other initiatives as well. We're always looking at how we can work and consider these. So I think yes, we would be interested in that. And I think that's definitely please get in touch with that kind of if you do have queries about that, because there's always opportunities to work on these things further.
Andres, was something you wanted to say it then?
No, I mean, fragility, that's the next step. When you want to evaluate the risk, in particular the impact, that's when you need the fragility curves. And we haven't looked at this one for this version of GeoCoast, but as Chris said, it's something that is a logical next step.
That's great. Thank you, Andres. I'm conscious still quite a few questions here. So as a team, we will reach out to individuals who have some questions still raised. Some are relatively sensitive, confidential questions. So we will make sure we speak to those people, those individuals one-to-one going forwards. But it's great that this has generated some interesting questions and comments. So I appreciate everyone for both attending and also posting your comments. Thank you very much, everyone, for attending, and I appreciate also the support of my BGS colleagues in putting together this presentation, the webinar today. We hope you found this webinar of interest, and I say we will make this recording available. If there is anything further, though, please do get in touch with myself or one of the team, and we hope you enjoy the rest of your day, and it's a goodbye from us here at BGS. Thank you.
Cheers. Thank you, everybody.
Bye.
Thank you.